Assalamualaikum warahmatullahi wabarakatuh. I'm Hamia binti Uthman and I'm gonna present about my final year project, which is the smart street light using Arduino Uno and infrared sensor with SOS button. So the first one is the introduction of the smart street light is actually introduced due to the growing interest in smart city initiative because of the urban expansion and the needs of sustainability, which is to save the energy consumption from the street light. And secondly is this project is also introduced with SOS button to enhance the safety measures and emergency response in urban areas, such as the targeted area is Taman Rambai Tengah Phase 3. And then there are two problem statements, which is first, the inefficient energy consumption in street lighting. So Malaysia's current street lighting system faces challenges of excessive energy consumption and dependence on timer controls, where there are also research from 2018, the prevalent use of conventional bulbs, metal halide, and also high pressure sodium contributes to the inefficiency of power consumption saving. And then the research also there are research from 2017 that emphasized with selecting the energy efficient bulb as the important step towards improving the lighting system. And the second problem statement is the safety concern pertinent to criminal activities. So according to a local newspaper, which is The Sun, the crime index in Malacca from January 1st to July 15th of 2023 is recorded at 749 cases. And the Malacca police chief, which is Datuk Zainul Sama, said that there were also 164 cases of violent crimes, which is unchanged from 2022. And there were also murder case and also rape cases as well. Therefore, this idea is to improve the public safety by incorporating the SOS button into street light is a must. And in the case of a crime, this system will make use of the widespread presence of street light to give people an easily accessible way to signal for help or assistance. And next is the objective, which is first to design the street lighting prototype that respond to environmental condition and pedestrian activity. And then second is to develop a street lighting that respond to environmental condition and pedestrian activity to optimize energy consumption and also to ensure the adequate illumination. And then the third one is to test the energy consumption of street light prototype and response time of SOS button. And the function of the street light, first, it will turn on during night time because the LDR does not detect any object, and it will turn off during daytime because LDR detects light. And secondly, at night time, the LED will turn brighter whenever the IR sensor detects an object, and then the LED will turn dim whenever the IR does not detect any object. And this function are to make sure that it will save energy. And then the power consumption calculation will be collected via ThinkSpeak, and then it will be saved into Google Datasheet, where the Google Datasheet then will be sent into our email. So next one is the function of the SOS button. So the SOS button will send notification via WhatsApp using a bot whenever someone pushes the button. And secondly, whenever someone pushes the button, the buzzer will make noise for a few seconds. And the next one is the image of the prototype. This is the image of the prototype. And then this is the image where whenever the IR, the infrared sensor does not detect any object, which as you can see on our left side, the LED is a bit dimmer, and then on our right side is the LED is a lot brighter whenever the infrared sensor detects an object. So this is the result from ThinkSpeak data. So the left one is the result before automation, which before automation is where the prototype is without any IR sensor or LDR sensor, where the brightness of the LED will be on a static level, even if there is any object or light. I mean, not lights, just any objects. And the second one, the on our right side is the result of the automation, where as you can see there are few spikes on that graph. And then the next result is basically the data that was sent from Google datasheet into our email. So on our the picture of on the left side is actually the coding for uh, Google datasheet to pull the data from ThinkSpeak, and on the right side is basically the data from it, and this is the result of SOS button. So I did a few testing on it to ensure the functionality. So as you can see, on the emergency notification, there is a coordinate of the SOS button, which is like that. Moving on to our project limitation, the first one is the Arduino Uno instability. Basically, the inherent instability of Arduino Uno may introduce performance issues that I encountered in this when I did this project, and then it also lead to erratic behavior and inconsistent outcomes, and then potential disruptions in functionality could compromise the reliability of the smart lighting as well. And secondly is the false alarm transparency. So the lack of clear distinction between false alarm and also genuine emergency poses a limitation in this project. And addressing this limitation is crucial because uh, it can enhance the system's accuracy and responsive. And the third one is ESP8266 not MCU version 3 vulnerability. So the ESP8266 is a cost-effective Wi-Fi microchip, and it exhibits vulnerabilities like frequent resets and also uh, unreliable internet connection. And these shortcomings also impacts the system overall stability and also the connectivity. And then the uncertainty in emergency assistant, which even after emergency notifications are sent, the project also lacks on the visibility on whether assistance will be provided promptly. So the efficiency of the emergency response post notification remain uncertain and highlights the potential gaps in the system. So basically, this is the recommendation of the project. The first one is to consider substituting Arduino Uno with Arduino Leonid for enhanced stability. So basically, whenever we consider to substitute consider to substitute Arduino Uno with Leonid, Arduino Leonid to enhance the stability, and the Arduino Leonid offers a comparable compatibility with shields and also sketches while potentially mitigating the cost concern. And the second one is to consider substituting ESP8266 to Arduino MKR 1000. This is because the Arduino MKR 1000 is a, com- a comprehensive kit that includes all necessary components in a consolidated package, potentially addressing the connectivity issues that ESP8266 has. And then the third one is to implement a 360-degree video system. This is because implementing a 360-degree video system to boost the emergency response reliability. And this innovative is an addition to record visual information upon SOS button activation, providing critical context to responder and aiding discerning the legitimacy of emergency situations. And also the incorporation of visual data can also contribute to addressing the uncertainties related to the willingness of individual to respond post notification. So, in conclusion, the combination of Arduino Uno and infrared sensor and SOS button in smart lighting presents a dual prong solution for energy efficiency and also the safety in urban settings, while adaptable to ambient condition and aligned with smart city objective. The system's limitation like Arduino Uno instability necessitates ongoing refinement and feature consideration including Arduino Leonid and Arduino MKR 1000 hold promise for enhancing the system's efficiency and contributing to the discourse on sustainable urban development. So that's all from me. Thank you so much.